Okay, so I said we're talking about radicals. So this symbol is a radical. So usually we say like square root, right? But it's not just like what's the square root of 25? Right. It doesn't mean 25 divided by 2. It means something squared, something times itself equals that number. But it's not just used for square roots. It could also be used for cubed roots, or fourth roots, or fifth roots, or sixth roots, or whatever. So the symbol is actually called a radical. Root is different. So if there is no number right here, there's an invisible 2 right here. That means what squared equals 25? The answer is 5. So there's nothing, if I had like the cube root of 25, what times itself equals 25? There's nothing that would come out nicely. Like 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. So 3 cubed is 27. So I'm going to guess this is probably 2.9. Blah, 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 blah. It would be an infinitesimal. So if you have to write something down, you probably have to round it off. But if I said what's the cube root of 125, you guys know what that would be? 5.
Yeah.
Because 5 times 5 is 25, and 25 times 5 is under 25. Kind of like 5 quarters makes $1.25. Anyways, what if I said cube root of negative 125? I think we talked about this before. Negative 5 times negative 5 times negative 5 is negative 125. That works. You guys remember when it didn't work? Kind of didn't work. This is going back to like chapter 3. I don't remember what chapter, but square root. What times itself equals a negative? Nothing. Because positive times positive is positive. Negative times negative is negative. Is positive. So this is imaginary, so we just turn this into a 5i. I don't think there's any i's on this lesson, but that's not really what this is about. That was just a reminder. Okay. Do you have to do it without a calculator? No, probably not. All right. Let's I'm not going to say you have to do 1 through 12 without a calculator. Yes, that's what the directions say. But let's jump to number 13 and look at those. Negative 25 A6B2. Have we done something like this before?
No. Probably.
Can't remember. Okay, so for the negative, it's nothing's gonna happen to it. It's just the problem's just gonna stay negative. Each of these things, each of these things is kind of in its own square root. Like this is the same thing as this. Okay, so we can do all these separately, basically. What's the square root of 25?
5.
So just a normal 5 is going to come out of that. What's the square root of a to the 6? I can't remember if we've done this before. What times itself equals a to the 6?
A to the 3rd?
Yes, a to the 3rd times a to the 3rd. You guys remember exponents? Is a to the 6th. You guys remember, so in this case we would add the exponents. You guys remember when we multiplied the exponents? In that case, you would multiply, because these two actually kind of mean the same thing. A third times a third is a third squared. Anyway, I don't know what's wrong with my throat. Law. Okay. What's the square root of b squared?
B.
B. keep rolling. Number 15, 162a cubed. All right, the square root of 162. Does 162 have a nice square root? No, it does not. But it can simplify. Some of you, a couple of you on the test, I noticed on that problem, not exactly this problem, but I think the problem was like square root of 80 or something on the test. I don't remember. A couple of you I could tell didn't have a calculator because you did this. Which is fine, but might get it wrong in that case. Yeah, if you don't have a calculator, you have to use the tree method. You don't really nice have a decent calculator. What goes into 162? And when you do like cubed roots and stuff, and different roots besides square root, even calculators can't do it. So maybe it's good for all of us to learn this method. And 81 is 9 times 9. We could break down the 9s again, but really since they're doubles, you can kind of stop right there. So we have a double 9, so that's going to turn into a normal 9, because basically the square root of 81 is normal 9. And then the 2 is left over, and that's going to stay in the square root. And I'm actually going to leave a blank. I kind of screwed up. I'm going to leave a blank between the 9 and the square root because I still have some letter stuff to take care of. And that's normally what you're going to want to do. Okay, if you're not good at this, you just need to borrow my calculator or somebody else's calculator to do it for you. But if we get into the cube roots, which we eventually will, you kind of have to do it. Anyways, a cubed. So, I'm pretty sure we've done this. Oh, it's been a while. So, when you have the square root of a cubed, basically what we're doing is 3 divided by 2. Does that ring a bell? Anybody? No? Okay. So, you do the power divided by the root, 3 divided by 2. So how many times does 2 go into 3? Once, with a remainder of 1. Okay, so what that means is there's going to be 1a on the outside and 1a on the inside. You guys remember that? Are you sure? Nobody? Brock, you remember that? Okay, you can start that then.
I mean, it makes sense, but I have no recollection of
I mean, it possibly could be my other class, but okay. Whatever. So basically, I don't know if I should explain why this works. Probably just confuse you. What I'm doing is I'm splitting the a third into a squared times a, because I can actually find the square root of the a squared part, and then this just stays in the leftover. It's kind of like this, but yeah, just think of it as a division problem if you remember how to do division. It's probably the easiest way to think about it. 3 divided by 2. I think that's how I think about it normally. Okay, anyways. Jackpot. Alright.
What if the A was just an A on the inside?
Okay, if it was just an A, that's a good question. If it was just an A on the inside, it would not simplify. So it would just say square root of A. Same thing if it was like a 7, like this whole thing doesn't simplify at all. So they wouldn't do that to you, but if they did, you would just leave it as it was. Sometimes you can't simplify. Number 17. Uh-oh. Oh no. What's different about 17? If you're not panicking right now, you should panic. It's a cubed root instead of a square root. Which means your calculator probably can't do it. It's not up. Although I'm sure there are some calculators somewhere that can, but I don't think any of the ones in this room can. So we're going to use the same method, but instead of looking for a double, we need a triple for it to have a cubed root. Because three things need to multiply together for it to have a cubed root. Anyways, what goes into 135? Well, it ends in 5, so I know 5 goes into it. How many times? I believe 27. What goes into 27?
3
and 9 is 3 times 3. So look at that, we got a triple. So the triple 3 comes out as a normal 3. Because basically the cube root of 27 is just 3. So this triple 3 is going to turn into a 3. And the leftover, a 5, is going to stay behind. If there was a leftover of like a 5 and a 2 or something, then we leave a 10 inside. But there's just a 5 in this case. All these things are multiplied together to make this thing. Basically, that's what this means. 5 times this times this times equals 135. And if you break it into 5 times 27, 27 has a cubed root. So that's why it turns into the normal 3. But 5 is left behind. I left a little bit of space here, probably not enough. Because I want to put some letters in there, probably. Alright, how do we do the letters? You guys remember what I did last time? 4 divided by 3. How many times does 3 go into 4? Once. 1 times 3 is 3, with the remainder of 1. So it's going to be 1 on the outside and 1 on the inside. So it's going to be A. I don't know why I switched colors, but yeah. And then what's the cubed root of B cubed?
B.
Yeah, it's kind of like 3 divided by 3 is 1. So it's just B to the 1 on the outside and no leftovers. So there is no more B left on the inside. Okay? Is anybody panicking? Are we in physical pain yet? Say yes. No. Cooper did. Okay, number 19. Fifth root. Uh-oh. You're not panicking. You should be. As Mr. Bell said, oh, this is bits. Mr. Bale's gonna outlive you, David.
What?
Said Mr. Bale's gonna outlive you.
Probably.
Because you done. Alright.
Something on the back of it, don't break your arm.
What?
Mr. Bell there saying,
What he said?
pat yourself on the back and don't break your arm.
Alright.
You're so smart.
So on this one, since it's the fifth root, I need 5 of something for it to come out as a normal. So I'm guessing there's going to be 5 2s because I see 2 goes into that. That would be 1 1 2. Possibly doesn't simplify, although I wouldn't count on it. 2 goes into that. That's 56, right? 56 is 8 times 7, and I know a lot of 2's go into. A lot of 2's go into that. So 1, 2, 3, 4, 5. Oh, what a coincidence. We got 5 2's. If we had a 6th 2, by the way, it would have to stay behind with the 7. And 2 times 7, 14 would be left behind. But we don't have a 6th 2. I'm just saying, if we did, it would be left behind. So these 5 2's are going to become a normal 2. Did I leave enough room? Probably not. We'll see if I can squeeze it in there. And the 7 is left behind. Okay, so for the x's, we're gonna do 7 divided by 5. How many times does 5 go into 7? Once with the remainder of 2. So 1, you can put a little 1 there, I guess, with the remainder of 2. Okay, and how about the y squared? What's 2 divided by 5? Well, 2/5, right? It doesn't really work with the y's. 2 divided by 5. That doesn't simplify. So that's kind of what Cadence asked about earlier. If it doesn't simplify, just leave it alone. Put y squared in there. And definitely did not leave that for me. Okay, but for the z's, what's 8 divided by 5?
1 with the remainder of 3.
With the remainder of 3. So it's z to the 1, or just z. And then the remainder of 3 means z cubed is going to go. Is that legible? Probably not. I'll rewrite it. 2xz, fifth root of 7, x squared, y squared, or third, sorry. Where am I at? Like 21? 21. Negative. Okay, so the answer is going to be negative. We're back to a square root. So on square roots, I don't really care. You can plug in square root of 192 in your calculator if you want to. Just for practice, I'm going to go ahead and do the manual labor here. Okay, so 192, it's an even, it ends in a 2, so I know 2 has to go into it. 192 divided by 2 would be 96. That's even, I know 2. Well, it's also 3 would go into that, right? And that's like 8 times 4. This one's kind of a mess. This is a square root, so we need to take all the doubles out. So that's 1 2 that comes out. That's another 2 that comes out, and that's another 2 that comes out. So what comes out? You're right, 2 times 2 times 2. 8 comes out. And there was a negative out in front, so we need the negative out in front. And what did I not include in that mix?
3, 4,
The 3 left over. The 4 turned into 2, so it's not really a bottom branch. I'm only using the bottom branches. But that 3 was left over, so. Let's see, I'm going to need a couple spaces. 3. Yeah. Okay. And then for the x's, I got 12 divided by 2, which is 6. And no remainder, so there's no x's left behind. And then for the y's, I got 15 divided by 2. How many times does 2 go into 15?
7 with the remainder of 1.
7 with the remainder of 1. When you're dividing by 2, the biggest remainder you could have is 1. Anyways, so 7 with the remainder of 1. Zoned out. All right. We're done with that section. We're almost through. 23. Kind of the same thing. There is a difference. I'll explain it, but this will be really short. x to the fifth. So how do we simplify that? Remember, if there's no number right there, there's an invisible 2. So we're going to do 5 divided by 2. What would that be?
X squared.
Yeah, it would be 2 with the remainder of 1. So 2 with the remainder of 1. Okay, B has something that's a little bit weird on it. I'm going to make a note of it, but I'm not going to make you guys have to do it. I decided it's probably more trouble than it's worth, and I don't think you really need to know it for high school level. So I'll just mention it, and then we'll just keep going with it. So what do I do for B? Right, 6 divided by 2, x3. Okay, now, here's the thing. The book put absolute value on the answers. Why did they do that? The reason they did that is because x is possibly negative. And if you do a negative number to the 6th power, it would become positive, and then you do the square root, it would be positive. But over here, if I put a negative in to the 3rd power, it would still be negative. So they wouldn't be equal. If x were negative, these two things would not be equal unless you put an absolute value. So basically, if you have an even power right here, and an odd power right here, this would have to be absolute value to be technically correct. I don't know if I've ever gotten students to remember that trick, and I think it's maybe more of a college level idea, so we'll just say I'm not gonna hold you to that. So if you just put x to the 3rd on a problem like that. Now, why didn't we do that on 13 through 22 is because they said assume all the variables are positive numbers, so it wouldn't apply. Anyway, letter C, x to the 7th, square root of x to the 7th. So 7 divided by 2, basically. The remainder of 1. So x to the 3, and then the 1 left over. A little bit weird. So 6 divided by 4, right? How many times does 4 go into 6? Once with the remainder of 2. Did they simplify this? Yeah, they did. No, they didn't. Never mind. They didn't simplify it. Okay. We're good. So 1 with the remainder of 2, so it's 1 with the remainder of 2. So notice my radical is still a 4th root. People forget that a lot. Whatever the root was to start with, it should still be the same over there. Okay, or D, that was A. 7, 4th root is x to the 7th. So 7 divided by 4. How many times does 4 go into 7? Once with the remainder of 3. X to the 1, x to the 3. And then 4th root of x to the 8. So what's 8 divided by 4? 2 with no remainder, so I don't need a square root at all on this one. I guess I'm done on it. Alright. 1 through 12, I said I was okay if you use the calculator, I don't really care that much. You would have to do a lot of trial and error to, well, I guess you'd have to do the tree method is what you'd have to do. That's okay, you can use your calculator. We'll give you some easy ones. You guys want to see your test? Are you excited about the opportunity?
I'm sorry. Yes, please. What did you say?
The final, yeah.